Hi everyone, thank you for coming to our plastics research presentation. I'm Melanie Carr.
I'm Jack Stroud. I'm Coleman Gould. Max Tebow.
I'm Monica Sherry, and I'm Hannah Van Alstein.
So as many of you might have seen last night in the art gallery, and as you travel around Eleuthera in the next few days, plastic is a reoccurring issue, and it also poses many problems worldwide. So plastic, 5 to 12 million metric tons of plastic enters the ocean yearly. Also, plastic is buoyant and plastic is persistent, meaning it doesn't biodegrade, but it breaks down into smaller and smaller pieces. So to give you a more visual representation of how this affects us, this is the Pelagic Food Web. So, as you can see here, these are macroplastics, and that's anything larger than 5 millimeters. And when macroplastics enter the ocean, they photodegrade, which means the sun breaks them down and wears them, and then they slowly get smaller and smaller and gaining surface area. Then they're classified as microplastics, which is anything smaller than 5 millimeters. Now, there's zooplankton, predatory fish, and prey fish. And zooplankton and microplastics hold very similar characteristics as size and color. And prey fish, it can be assumed that prey fish might accidentally eat these microplastics, assuming that they're zooplankton. Now, predatory fish then eat these prey fish, and it poses other issues. Now, we might ask, why does this matter?
POPs, or persistent organic pollutants, which are toxins that come from factory byproducts, herbicides, pesticides, flame retardants, and more. POPs, when they're in the water, are hydrophobic, which means that they don't want to touch the water, so they will latch onto anything that is floating on the surface of the water. And a common material they will find is plastics. As well as hydrophobic, POPs are lipophilic, meaning that if a microplastic is to be consumed by a fish, then the POPs on that plastic will suck into the fat of the fish. And this leads to a great risk of bioaccumulation of the food web, which basically means as trophic levels go up, there's a risk of the amount of POPs in a fish going up as well. And POPs have many health risks, which include increased risk of disease, birth defects, and hormone disruption. So why do we care about POPs? As I said before, there's a great risk of bioaccumulation. So once POPs reach predatory fish or sport fish, which we commonly eat, there's obviously a great risk of us, people, consuming these POPs and facing the consequences.
Okay, so if you can see on the map to your left, this is where we're located, the star, and we are on the bottom of the North Atlantic subtropical gyre, which runs up and down the east coast of North America, right here. And a gyre is dangerous because it's a common accumulant for plastics. So with the Exuma Sound, which is where our study was located, there's 2 entries, as you can see right here. And due to currents from the North Atlantic subtropical gyre, plastics, potentially there's a larger density of plastics in the Exuma Sound. And according to a previous study done in the Exuma Sounds by Lavender Law, there's approximately 5,000 to 10,000 pieces of plastic per square kilometer.
Alright, so for our study we set out 4 main objectives. The first objective was to quantify the density and spatial distribution of plastics in the Exuma Sound. The second objective was to determine if pelagic fish are actually consuming plastics, and if so, which types. The third objective was to determine if pelagic fish are accidentally or preferentially consuming plastics, and with the occurrence of Hurricane Joaquin, it presented the unique opportunity to look into, see if tropical storms and hurricanes are having effects on plastics in the Exuma Sound. So during the data collection process, we used 3 methods. The first method was conducting a high-speed trawl. This is the trawl in action. During this process, we put the trawl net over the side of the boat and dried it for 15 minutes. Any marine debris on the top quarter meter of the water was funneled down into the cod end or end piece of the net. And then the cod end was taken off the trawl after and taken back to the lab for further dissection. This is the second method, which is fish dissection. As you can see, this is a wahoo mid-dissection. During this process, the fish's stomach is removed. It is then cut open and the stomach contents are put through a sieve. Okay, the last method is sorting. During this process, the contents of the cod end, which is contents from the trawl, and the fish stomach content are put through a sieve until it's only the plastic particles left, and then the plastic particles are sorted by shape, weight, type, and color.
So this is a map of the North Exuma Sound, and we are located here by this pinpoint. Any of these markers show where a trawl was conducted, and the circles represent when a trawl was conducted before the hurricane, and the cyclones represent trawls that were conducted after the hurricane. As you can see, there is a much higher density of plastic per square kilometer after the hurricane, such as this point, which was found to have 6 million pieces of plastic per square kilometer. So this is a graph of the average density of plastic before and after the hurricane. And as you can see, there's a great increase in density after the hurricane. However, due to the large margin of error, the t-test run on these results was inconclusive. This is a graph of the proportion of macro and microplastics in the trawls before and after the hurricane. As you can see, there is a much higher proportion of microplastics than macroplastics. However, there was a slight decrease in proportion of microplastics after the hurricane. So out of the 101 fish that we dissected, 30% of the fish were found to have plastic in their stomachs. And we used fish like wahoo or dolphin fish or tuna. And the most common types of plastic that we found were fragment, line, or film. And the most common colors of plastic that we found were clear, white, and blue. And then if you compare this to what the plastics that we found in the trawls, there is a similar type of the most frequent type of plastic found in the trawls, which is fragment, line, paint chip, and film. And then there's also similar color proportions, which are clear, white, and blue.
So the next question posed is, why does this matter? What do these results mean? So as stated in our results, there were more microplastics found in our study than macroplastics, and this suggests a potential high decay rate, which is due to photodegradation, which, as Mel said, is when the sun and other weathering factors break down these macroplastics, making them into microplastics. We also looked at the effects of Hurricane Joaquin, and although we found no significant change, as our t-tests were inconclusive, we noticed that the proportion of macroplastics increased, and this is likely due to macroplastics blowing into the Exuma Sound during the storm, and the microplastic proportions actually decreased, and we believe that this is because of a widespread distribution due to storm currents. Another huge part of our study was that we found a higher percentage of the fish that we dissected contained plastics compared to previous studies. For example, Choi and Drazen conducted a study in 2013, and 1% of the dolphin fish that they dissected contained plastics. However, as Annika stated before, 30% of the fish that we dissected, which included dolphin fish, contained plastic. So that's an obvious, very large increase. So what are the impacts of this? There's a variety of ecological impacts, including a threat to fish due to these POPs. Since we know that these fish are consuming plastics, if they're consuming these POPs as well, it could cause a potential decrease in the population of fish. As shown in the food web, these POPs could also have an effect on us humans. If humans start to ingest POPs, a variety of unknown and understudied effects could occur. These POPs could be potential carcinogens. In addition, this could also have a large effect on the economy. In the US alone, the recreational fishing industry is worth $70 billion. The Bahamas is also very reliant on its fishing industry, and it's especially important to note that the Bahamas in Eleuthera is also focused on this fishing industry as well. So if, in fact, fish are consuming plastics, that's going to cause an obvious decline in these industries, harming the economies worldwide. We would like to acknowledge our advisor again, Zach Zuckerman, as well as Connor Gallagher, Tony Ann Keeling, Phoebe Colvin-Omig, and Will Lee. We'd also like to thank the Cape Eleuthera Institute, as well as 5 Gyres. Here's our literature cited, and does anyone have any questions?
The width of the, I don't know what you call it again, but the thing that was capturing the plastics, if you were to make the opening there like twice or 3 times the size, do you think that would have had an impact on whether you're catching micro or macro plastics?
So the question was if we opened up the size of the trawl opening, if that would have an impact on the macro versus microplastics. Okay. I am not certain, but there is still a higher quantity of microplastics in proportion to macroplastics, and that was found in all of our trawls. So I would probably say there's still be a much higher quantity of microplastics.
Yes. When you're saying you have much bigger, higher quantities of microplastics, are you counting like individual pieces, or are you counting it by weight?
So the question is, since we have more microplastics, how are we categorizing these? Or is it by weight? So during this process, we do categorize each individual piece of plastic, and we're doing it by type, shape, weight, and color for each individual piece.
But like you could have, a cubic centimeter of microplastics that contain, 1,000 pieces, or you could have one, coffee cup, exactly, are they measured 1,000 versus 1, or
so the pieces are actually individually counted. So when we say the density, they're actually individual pieces, no matter what size or weight. Yeah.
There doesn't seem to be any recycling program at all on this island, so I actually have about 3 bags of stuff I'm thinking about taking back on the plane with me because I can't, I don't want to throw it out. So what is the state of recycling here?
So a big problem in the Bahamas, and the problem is in the Bahamas there's not a proper infrastructure for recycling. So what happens is usually most plastics just go to the burn sites where they burn all the trash. So it's kind of a problem in the Bahamas.
When you cut the fish open, did you find that certain species had more plastic than others, or was it pretty standard across the board?
So we had 3 main species that we dissected, and although there was a slight variation, there's between, I think, 27 and 30% of of fish that had plastic. So it's roughly the same percent of fish.
That's a very good question. The question was, is the plastic that's in our oceans coming from just the Bahamas or from everywhere around the world? It's actually coming from everywhere around the world, which is a big issue because we don't know where the plastics are coming from. So we can have plastics in the Bahamas that are coming from Japan or China, and we don't know due to these currents.
Will you talk a little bit more about the different types of plastics you found and what the end sources, the original sources of those are, if you know?
So the question was if we could talk a little bit more about the type of plastics we found. We found everything from paint chips to fishing line to fire nurdles, which when we get things in a box from Amazon or something, they send those little packets with beads inside of them. Those are called nurdles, and usually what happens is they just go right into the ocean, and those are one of the biggest issues because there's so many of them. So we found a lot of those, but a lot come from fishing line, and the small pieces of plastic is really hard to see what it came from because they're so broken down, but you can still see if they're film or what degree of kind of how long they've been in the ocean.